Hello everyone, welcome back all to the part 2 section of the same topic as are you following the SQL Server development best practices? Um, in this session, we will cover the remaining areas. Now, let me show you very quick what are all the topics. So we finished in the previous part until the indexes. In this part, we'll cover from Transact-SQL, then version control, the queries and store procedure, the process improvement, consultation, and finally we'll end with the security. So with this, let's get started with the data purging and cleanup. Data purging and cleanup. So it is another important area, one of the important areas while we talk about the best practices of SQL Server. Why so? Uh, so now the developers may not actually have the access to run through the data purging, right? So it's not like all the steps are being performed by the developers. It's more like how somebody can boost the performance while looking at all the features and all the points which I'm actually discussing. So let's say you have a table, right, which is for example maybe order or maybe something which has been running for several years. Let's say it is pumping the data into the table, right? But let's say your application or any user actually do not need to go back and check more than 90 days or maybe 120 days of data. So many applications, basically those are designed only to check only 90 days or maybe 120 days. But again, in the database, you still see that even beyond 120 days, maybe the data are all lying, because they feel at any moment if they need to retrieve the data, it will be easier, because if they move everything to a data warehousing solution, from there to bring the data will be a if it's a tough challenge. So as long as the data is standing in the existing database, it might be easier to pull the data. So which is actually not a great practice by any chance, because if your application itself is designed to get the data for 90 days or 120 days, or if your app is obviously applications is your app, then definitely it doesn't make sense really to keep all the data piled up for years together. So in order to improve the performance, it's always better that we run through a cleanup job, through a, through a, not a manual way. Maybe we can run a job, and based on how much data is being, inserted into the table, we have to choose either we need a daily run, or it's a weekly run, or maybe bi-weekly run or something like that. We have to understand how many records are going to be inserted, and we have to take a call accordingly. That way the performance will be way better, because your index size will be smaller, obviously, because it has less number of records in the table, and obviously the number of records it has to scan through or seek through, definitely it will be faster, right? The next point is create appropriate strategy to write your own script to clean up the records from from the table. So do not use any script being given to somebody, because in his environment might be he uses some way, maybe in your environment you use into some way differently. So those are different, right? So you actually cannot use the same script being used by somebody, because in your environment you may have a primary key table, you have a child table. Definitely you need to delete the data from child table, then followed by primary. So those sequencing you have to understand very well before you run through your your script, basically. So identify the base table and delete the record from child table, as I just said, right? So create your cleanup logic accordingly. That while you design your script, okay, always try to use the temporary table rather the table variables, because let's say if you are taking a large number of records, and based on that you are setting up your condition against the other tables to delete the data, let's say. So if you're using a table variable, that is actually designed for a smaller number of records. But if you actually are importing a huge number of records during its cycle, then definitely it's always better that you use the temp table over the table variables, because that's how the design, right? We need to use how the flexibility offered against each utility like temp or table variable, like that. The third point is, before you initiate the cleanup, ensure you have the correct indexes. If not, create accordingly based on delete condition column. So before you start the cleanup, as I said, always ensure that you have covered through the proper indexes, because if you do not have, let's say you're deleting some of the records, and if you do not have a proper indexes, it will take more and more time, right? So understand what is your delete logic, what are the columns it's actually using, and then based on that create the indexes, maybe temporary until you have the purging solution is over, but at least create them. If needed, create appropriate non-clustered indexes on temp table. So now, as you know, table variable doesn't allow creating any indexes, but temp table does. You can always consider to create an index onto the table, non-clustered indexes on the temp table, because that definitely will improve upon your performance up to a great extent. So before you start with your task, ensure you have created basically the non-clustered indexes if needed. And obviously there are commands through that you can write a query, and then you can see which indexes which you have created maybe recently, which can improve the performance, which is not improving the performance, and you can have them, or probably you can remove those indexes based on the results what you see. Now the next important point is the database objects, um, which is another obviously very important area which we have to consider. So I have created three sections in the database object section. So one is use user defined constant names rather using system generated names. So many a times you might have seen that people create the the table name just like that, or maybe index name, and they allow the system to create any arbitrary name. So I would always suggest that, instead of that, take your own control and create the name of the objects with a proper naming standard. That way, that by looking at the name, you can easily identify, yes, that these are the columns, or maybe this is how it has been created. You don't have to spend too much of time on that, right? It reduces your overall effort. The next point is, while creating your own procedure, make it start with a USP rather using SP. So why so? Which is very important, because it is a standard naming convention that is used in the master database. If you do not specify the database where the object is, SQL Server will first search the master database to see if the object exists there, and then it will search the user database. So what it's trying to say is, let's say the moment you create any procedure, it will first start to see into the master database. If you do not specify the database name where the object is, where you are setting that, SQL Server will first search the master database to see if the object exists there, and then it will search in the other. So that's actually a more time consuming. Instead, you better designate the USP and then also mention the database where you are, so that it immediately will go and check in the designated database, rather search from master and then all the databases one by one, right? So definitely the performance improves. And also you can easily identify, okay, USP means user store procedure, so you can understand it's actually created by you, not by the system, right? And the last point in this section is user objects to go to its respective file groups. Do not create user objects and data to sit in the system or primary file group. All system tables are allocated in the primary file group, which is very important, because if you create the user tables and user indexes into the primary file group, it is actually less secured, because anybody can use that. Instead, you can protect them using a specific file group, so that it creates a hidden by outsiders, because they don't know which table might be sitting in which file group, right? It's you who knows, but other user do not know. So that's way you are creating more security across your database objects. The next point is the next section is the Transact-SQL, which is again another very important area, right? So why so? Because Um, Regular join statements in two or more tables in your query will be performed faster using the proper indexes if those are present. So for example, you are writing a query and that requires a multiple join statements, right? It might involve two tables or maybe more than that. Your query might perform faster using if you have the proper indexes are present, right? Because it can map the records very easily, right, between both the tables. So definitely you get a better performance. If you do not have, better off you create them and then you write your query. Do not over-index your OLTP tables. So if you have an OLTP and if you feel maybe if you can create another 5 indexes and tomorrow the performance would be better, it doesn't work in that way, because index always function like a double sword way. So one way it helps to improve your select query, other way when you insert in a query using insert, then definitely it increases more constant check, right? So one way to improve performance, other way it actually reduces the performance because it increases the conditional checks. So you want to avoid by creating unnecessary indexes in the system as much as possible. The third point is you use appropriate begin, tran, commit and rollback statements. um, Transaction inside the code block. Okay, use try catch blocks as well. So what it is saying is, as per the SQL Server, the way it is written, either the entire transaction will be committed or entire transaction will be rolled back. That is how the design of SQL Server, right? So in your case, I mean, in your code block, let's say you're writing a procedure and that has multiple section, right? Use the appropriate begin tran and then take control by using a command like a commit or rollback, and also use the try catch block so that if in the event of any issues, it can trap the error and give it back to you what exactly the error, right? So any moment if there is any error, it will immediately jump to the catch block and it will hold the error and then it will give it back to you. So which is very important and better way of writing the code. Next point is, find the key columns which really require to be encrypted. Do not overdo. So in a table, if you have, let's say 20 columns, right, you want to protect the customer SSN details, maybe an I number, or maybe the credit card details, maybe the address, maybe the phone numbers, right? But if you have certain columns which nobody even knows what exactly the column, it's hard for other people to understand even. Do not try to encrypt them, because in that way, while your application reads the data, it has to uncrypt it. It takes more time to uncrypt, right? So performance doesn't improve, it actually hurts the performance. So discuss in your team, explain to your architects about that, and then you decide what option is better for you. Uh, Next point is, create non-cluster covering index on frequently performing same queries. So do not just create clustered index. Okay, if you need, create non-cluster covering index on the remaining columns, because obviously that way you can see improved performance, obviously, right? Yeah, so take a look at your execution plan. If you see there are some section which are covering where you need to create a non-clustered index, or maybe a included column index, or it's a covering index, feel free to create them, test the performance, and also look at frequently the execution plan to decide whether you really need that indexes. The next point is, choose correct fill factor. Page split actually hurts the performance, which is another very important point. When it comes to the OLTP application, okay, for OLTP application, what happens? Each data is actually residing into the pages, correct? And then if you give a very high, let's say 100% your fill factor, then what happens? All data are supposed to be into the one page, but any moment if you when you try to insert the data, or let's say 101 record is going to come, right? Half of the data page will move from one page and it will create another page. That's how the logic. So instead of that, do not try to create 100% fullness. Either try to create maybe 70 to 90%. In that range, you try to create a fill factor, right? So that way the percentage of fill factor would be reduced, and definitely that's better for your overall performance, obviously. So keep in mind those considerations. Next point is version and store control, which is very important. Maintain all your code in a source control system and update it always for all type of changes happening to the code base. So maintain the code into a code base, either it's a TFS, Team Foundation Server, or maybe a database project application like that, which is always a better, right? Because if you are making a changes as a developer, right, and then I am another developer, I'm making a changes, so when we extract the latest code, we should know who has made the last changes, right? So we have to extract based on the history. So whichever changes has happened the last, we want to consider that basically. So which is very, very important. So always maintain a proper version history. And let's say if you have multiple environments and which version will go to which environment, always try to maintain those details very carefully. Otherwise, it might can create a huge issues basically if those are not maintained properly. Queries and store procedure. Now that is huge. You can see so many points are there. So what it says is keep smaller transactions. So let's say you are writing a procedure and you have multiple sections in that, right? Instead of that, try to see if you can make it a smaller transaction. That way, if any requirement comes where it has to roll back, it doesn't have to hang up a lot, because as I said, it will either commit the entire transaction, or it will roll back the complete one, right? So it will take lesser time to roll back the transaction or even to complete the transaction if needed. Now the next point is avoid using the star command. Instead, choose the right column. So let's say if you're writing a command and you do not know what are all the columns need to be chosen, and then you always have a habit of creating the star, like seeing all the columns. So instead of that, uh, understand what are columns you want to see, and then based on only bring those columns. That way your query will be faster, your performance will be faster, and then if any other people who are also running the same commands, they that way the overall performance will be better. There may be lesser blocking and other locking into the tables, right? So definitely that is better. Avoid using query hints when you are not exactly sure. So many people, they have a habit of creating suddenly a no log or page log commands, or maybe UPD log commands. They feel instead of just giving a select query, if they can use a specific query hand, maybe that is better. So if you're not sure, do not use those query hints, because that doesn't actually help you. Instead, it creates a negative impact to your performance, right? The next point is use relevant the set no count on and off commands, which is very important. So let's say you are executing a query and then you don't want to see how many number of records are affected. Okay, then at the top of your page you use the set no count on, and at the end of the page you make set no count off. That way the network call will be reduced and you don't have to see unnecessary how many records have been impacted in each step of the query. Do not use unnecessary select statement in the code. So let's say you are doing an update and then followed by a delete, and suddenly you feel maybe a select statement is better. Now if it is for a testing purpose, yes, it's okay, but when you take that into your if you make that official the procedure, and if you really do not need the select command, don't unnecessarily write that. Better off you remove that, because that will increase more load onto the database, right? Carefully choose union, union all, and distinct the clauses. So union and union all, there is a little difference. For example, you are trying to make a union between two tables, right? It will actually try to eliminate the duplicate entries. However, if you're using a union all, it actually doesn't consider any, I mean, it doesn't restrict whether you have duplicates. It will combine everything. So let's say if somebody is asking you in an application to design, like you include all the records, I don't care about the duplicates, then you can better off use a union all, because the performance will be far better. It doesn't have to check to look for the duplicates. Or also you can do like union all, get all the data, and then you run through a distinct command. That way probably it will be better if really you need a distinct command to find the distinct records. Avoid using rtrim and ltrim function. Instead, correct the data. So many people, they they design the system in such a way that when the application through the application you insert some of the records, okay, it doesn't care, you can even have spaces or maybe special characters, and later when you design or write your query you actually have to use rtrim, rtrim, ltrim, and other commands to extract the meaningful records basically. So that's an overhead, because instead I would advise that correct the entry or design your application such a way that while you enter the record, you actually insert the correct record, right? You don't have to use anymore the rtrim and ltrim. Next point is avoid unnecessary use of distinct operator. Now, many people, for any reason, if they write a query, they feel that the table may have duplicates. So now, if you're running a command on a clustered index column, right, you know that column cannot actually have a duplicate. But again, you are writing a distinct because you are habituated to write in such a way. It doesn't help. Instead, it will have more load on the TempDB, because in TempDB, it has to sort out all the record and it has to give back, right? So it's a more load. So better off you avoid creating a using a distinct command in that case. Use where clause always. So let's say you are running a select command and then you do not know it, it tried to fetch a record and you forget to close the session, it's running forever, and then it creates a huge deadlock, maybe a blocking, and that can have a huge impact to the application, right? So instead, always use a where clause so that you know what data actually you really need to where. Same for delete. Okay, when you run a command like a delete or update, always ensure that you are using the correct conditions. Otherwise, it might be dangerous. It can either update all the records or it might be deleting all the records, which is dangerous. Coming back to the next point, which is design your system to fetch records using top operator, avoid accidental select star, which is very important. So you can always use a top operator. So for example, it is far better than a select star of all the columns, because you know top 10 records or 100 records are only you are fetching, which is better than invoking 1 million records, right? Which is still better. Then the next point is remove temporary tables from database after the operations. Those consume space, increase maintenance time. So if you have temporary tables, first of all, once you're done with the session, yes, it actually goes away. But yes, it's always better that you delete them. Otherwise, it will unnecessarily be piled into the TempDB, which doesn't make any sense. The next point is carefully choose the special characters. If not, uh, it may change actually the execution plan and lead to bad performance, because it can also create a parameter sniffing. So there are special characters in your keyboard, right? Maybe a teal character or any other special character. If you open a Win word and if you go to special characters, you can see a huge list of special characters. Now, in your application, when you are accepting any input, right, by mistake somebody can type and then it can import some special characters, then you design your system in such a way that in the system itself it will throw you the error message, right, instead inserting all the record in the table, because that has a huge impact. Because when your select query or any functional query that tries to read the data, if they see any special characters, that might can change the execution plan altogether, right? It can be very bad, the performance, and you might need to restart your SQL to make a better performance, or maybe you need to create statistics. So that can be very dangerous, right? If you have any online application or something, one day you see nobody can use the application, right? Definitely it can be dangerous. And if you need to restart SQL, means it's a downtime basically to your business. Now, avoid SQL Server to do implicit write conversion. Instead, use a correct data type. So let's say you need integer data type, right? And instead of that, you are creating a varchar. So SQL Server in such cases might need to create implicit data conversion, right? Which is again not good, because any kind of conversion means SQL Server engine needs to spend this time to do this conversion. So you can always see that while you run a execution plan, you can go to the properties and you can see what are all the implicit type conversion happening, and you can always rewrite your code or maybe change the data type accordingly. That is very much needed, right? Even though you have a table with a certain data type, if you later on, if you find that the data type is actually not correct, you can always correct that later on, obviously. But yeah, obviously test that into lower environment. Don't just start by making any changes. Now, the next point is process improvement. So it's not always that if you make your query changes, then only you will see a better performance. You might have to even look for process improvement, which is also very, very important, right? So document common mistakes in the lesson learn page or in your best practice guidelines. It is always a good to have this practice which is followed in PMP. They always suggest having a lessons learned page. Like for example, you worked on a project, after that what are the issues you have faced, and based on that you understand and discuss in your team, and your team gets understand about okay how to overcome such issues in future. Do review the upcoming SQL Server edition and change your script accordingly. So let's say you are running in SQL Server 2012. Let's say now you have SQL Server 2019, right? So you can always change your coding if you are in 2019. For example, we never had the previous versions create or alter statement. Now you have a create or alter statement. So if you're creating it, then it will create, otherwise it will alter, right? So create or delete statement, my bad. So that's actually been invoked in 2019, I guess. The next point is the consultation. So it can be both internal, external, right? You can check with your colleague, you can go to outside, but yeah, you cannot share your technical facts or personal the project details, right? But yeah, you can seek advice from other people, check with your in-house developers, DBS for any advice related to SQL Server best practice that they are following maybe in their team. You can seek for outside trainings. You can request to procure any third-party vendor tools, maybe Redgate, SQL Sentry, Foglight, SolarWinds, IDERA, or any other products, and check by using the tools and the recommendation which the tools are offering, helping you by any way. Use their trial version, do some POC to understand if that what specific tool can be best for your environment, and choose it wisely. Then now the next and the last topic is the security. So which is again a very important best practice configuration. Now why? Because remove the built-in administrator group, which is again not needed. The moment you have the built-in administrator, everybody automatically gets access to SQL Server, which is dangerous because you might never need to allow all the people to use SQL Server automatically, right? So always it's better that you remove the built-in administrator group from the SQL Server. Secure and disable the SQL Server SA account. Now you can actually disable. Even many people they prefer to have a SA account. In that case, you ensure that you change your SA password very frequently, at least maybe 90 days or 60 days of period, so that people, those who are leaving the organization, or who, if somebody knows accidentally the password, he cannot harm or damage to the environment. But yeah, overall, it's always better that you try to consider to disable the SQL SA password. The next point is turn off XP command shell at the server level to avoid kind of injection possibilities, right? So when if somebody is writing a query, if they have a SQL command shell, they can make many changes to SQL Server configuration. So don't keep left that command or let that property or turned on. Better you turned off the property and then just use it when your query needs that, and then again turn off the property. And the fourth point is never create individual user login. Instead, always try to prefer creating, the AD groups. Let's say for developer group, tester group, and all, and add users to the respective group. That is better. Which people are leaving. You don't have to specifically manage them. Instead, the better part is, always try to encourage people to use the Windows login account. That way, what happens if somebody is leaving, even you don't have to disable any SQL login account, that will automatically get disabled. The fifth point is change default SQL Server port. Now for SQL, the default port is 1433, but always try to change that so the people cannot guess about what is the SQL port, right? And the next point is configure SQL account with least privilege. So try to ensure that the SQL Server, I think these 2 points are missed here, but yes, we still have another 2 points, which is configure SQL accounts with least privileges. Now, SQL Service accounts, whatever are there, try not to give that as an admin, which is really not needed. That can be dangerous because if somebody knows the user ID password, he can actually try to do any kind of damage to the environment. And the last point is revoke execute permission to the public from extended SPs. So which is also important because if you're creating extended procedure, if you're giving a public access, anybody can access and run those procedures, which is not needed and can be harmful for your environment. So with this, we are done with the entire session. I think the part two is completed. Here are some of the useful references. I would encourage everyone to actually go through them. If you want to know a bit more about that, I would suggest that you review the MS SQL tips, the series. You can review the Microsoft MSDN article and the other useful links which I have mentioned here. So with this, I think we are end of the part two of the discussion of are you following the SQL Server development best practices. Before you leave, do not forget to like the video if you like the video, and then the presentation, and please go ahead, subscribe and share with your friends, colleagues, and I would I would be interested to see you all in the next video and with some upcoming sessions. I would also request everyone to suggest me what are the other technical database areas you want to see the videos, and I would be very happy to prepare the slides accordingly in my future videos. Thank you all. Bye bye. Take care.